This will be our final 2 lessons over circles. We're going to finish up today with circumference and arc length, and then we'll have one more lesson after this one covering area. So when we see the word circumference, we should think about the perimeter of a circle. And so that is the distance around a circle. All right, so when we're talking about circumference of a circle, we're talking about the outside of the circle. So how far around the circle is it? In this case, how many feet is it? So the formula for circumference is circumference is equal to 2 times pi times the radius. And you normally see this written as 2 pi r. So 2 times pi times radius, and then 2 pi r. Now pi is the relationship between the diameter of a circle and its circumference. So this is what we're going to need. So you can tell here we need the radius. Okay, so I come over here and I see I have 11, and 11 is the radius. So from the center out. So I know that the radius is 11 feet, and I'm going to substitute that in here. So the circumference is equal to 2 times pi times 11. Now when I get to here, I need to go to Desmos to do my calculator. So 2 times pi times 11 is what I'm going to need to type in. So I'm going to type in, so I've got 2, and I'm going to bring in my keyboard here. So I need to 2 times so 2 times, and now pi is right here. So pi is right there. So 2 times pi times 11. So I come up here, so 2 times pi times 11 is 69.1. So I come here, and I'm going to say that circumference is equal to 69.1 feet. Okay, so that's for doing the circumference of a circle. All right, so we're going to keep going, and now we get to arc length. So arc length, and so arc length, here we are. We're just looking for the length of just a part of the circle. So an arc length is just a part of the circumference. And arc length uses the letter S. So S for arc length. So S is equal to 2 times pi times r. Now if we stop there, this would be the circumference, but we only want a part of the circle. So times theta over 360. Now 360, because all circles equal 360 degrees, theta is just the angle that we want to use. So theta would be this angle here, so that would be theta. So I'll make a little note of that. So this is the angle we are using. And when I say angle, I'm talking about the central angle. So the central angle here, out of 360, so out of the whole circle. So I come over here and I figure out what information do I have. So 3, this is my radius, and then 150, that's my theta. So the radius is equal to 3 meters, and theta is equal to 150 degrees. So that means my arc length, remember this is just arc length. So S is equal to 2 times pi times the radius, but the radius is 3, times theta over 360, and theta is 150 over 360. All right, and once again, we're going to go to Desmos. All right, got a little bit more to type in this time. So I'm going to clear it out. All right, so we have 2 times pi times the radius, which is 3. And then we're going to multiply by 150 divided by 360. So we need to make sure that we have this fraction pop up here. So 2 times pi times the radius. Theta was 150 over 360. 7.9. We'll go to 1 decimal place, so 7.9. So S is equal to 7.9 meters. Meters will be your unit there. Okay. So I'm going to come down here. Now I'm going to go ahead and tell you that circumference, you're not going to have a whole lot of circumference problems. Most of your problems for high school geometry will be around arc length. And so that's what our problems are going to focus on here. So I'm going to come down and I'm just going to quickly write the formula again. So S is equal to 2 times pi times radius times theta and 360. So for all these problems, what I'm going to need to find is I need the radius and I'm going to need theta. All right, so I come down. Find the length of the arc that uses 100 degrees at its central angle. So there's 100, and that would be talking about this arc right here. So I'm going to take my time and I'm going to look at what do I have. All right, so 7 meters, so that's the radius. And theta is going to be 100 degrees. And now I just substitute in for here. So I'll come down just short a little bit. So arc length is equal to 2 times pi times the radius is 7 times theta, which is 100 over 360. All right, calculator time. So we have 2 times pi times, let me double check, 700 times 7 times 100 divided by 360. And I get 12.2. So here my arc length is equal to 12.2 meters. Okay. All right. Next one. So we want to find the length of the bold arc. So we're talking about this arc right here. So I see 6 inches. So that's the radius. So the radius is 6 inches. But now this 143 over here belongs to this arc. So I still need to know theta over here. Well, I know the whole circle has to be 360. So if I did, so theta is going to be 360 minus 143. So 751. That's 217 degrees. So that means theta is 217. So this angle here, 217 degrees on this side. All right, so now I have everything I need. I have my radius, I have my theta, and I'm just going to substitute in. So arc length is equal to 2 times pi times the radius, which is 6, times 217 over 360. So calculator, once again, I'm actually just going to go over here and do this. So we know it's going to say 2 pi, and then the radius was 6, so times 6. And then I don't want 100, I want 217. And this time I get 22.7. So 22.7 inches. All right, and one more to go. So we have find the length of an arc subtended by a 70-degree central angle and a circle with a radius of 10 centimeters. So if we want to see it, Just draw any circle. 70 degrees, that's less than 90. So not going to be very big. So this will be 70 degrees, and then the radius will be 10 centimeters. And we want to know this arc there. So my radius is 10. My theta is 70. And this one's going to be a lot quicker than the second one. So just substitute in. So S is equal to 2 times pi times 10 times 70 over 360. So once again, I don't need to erase the whole thing. I know this is going to be 70. And I know that my radius is now 10 centimeters. So I can get rid of this 6 and just type in 10. And that should do it. So once again, I get another 12.2. So my arc length is 12.2 centimeters. Okay, so every question that you do, you're going to need two things. You're going to need the radius and theta. Radius, theta. Radius, theta. You have to have those pieces of information to use the arc length formula. All right, good luck.